So what we will be doing, each day there'll be some lecture component. Put stuff up on the screen, PowerPoints, go to the web page, type in some code, let you see it, stuff like that. And then there's also going to be an in-class portion. All of it's in-class, right? In-class assignment, which is a tutorial where I guide you through writing a little program. And so sometimes that involves me, or quite often I'll just be writing code up here and you will be typing along with me. And that's why I hope that we can get the screen as good as possible. I need to perhaps make the screen a little bit darker when we get there. Or excuse me, the light's a little bit darker. So those are called in-class assignments. So we'll be doing a mix of those, lecture and the in-class assignments. The in-class assignments are to get you hands-on practice, so that if I give you a homework assignment and you go home, it's not like you've never seen it before, You will actually have experience in it. I will never give you any homework that is based on anything that we haven't already covered in class. So a chunk of your grade is based on your homework, a chunk of your grade is based on the in-class assignments, and then there are some exams. So as long as you're showing up every day and doing the in-class assignments, you've already got a really good leg up on your grade. It's not like you can blow off the homework. You still have to do the homework in order to pass or ace the class. But, since you get lots of points for being here and for turning in the in-class homework, the in-class assignments, please do so. Once you're done with them, make sure to upload it, because if you don't upload it, then I can't give you credit for it, even if you were there that day. And yeah, that's enough of that. Let's hit the syllabus. Let me zoom that. Carries out instructions that tell the computer what to do. So before transistors, before silicon chips, stuff like that, people were still creating computers. Some of the first computers, or the first ones, were actually hand-cranked gear computers. And then later there were computers with vacuum tubes, stuff like that. But nowadays things rely upon processors. And, that's a term that we're all familiar with, even if we don't, know how to build one. The Intel processor, the AMD, the ARM4 that's in my phone or whatever. So generally, what a processor is it's a device that once every certain amount of time, once every clock cycle, it accepts input in the form of a number. And so you can give it a string of numbers. And those numbers are called opcodes, operation codes. And along with the opcodes itself, you also pass in other values. And so what happens is you may have an opcode that's supposed to display something on the screen. And so there'll be some information, okay, I want to display something to this, okay, that's way too complicated. Load this number into this place in memory. It puts a 3 into that place in memory. Load this number, there's that word again, into this place in the memory, 5. Add those two numbers. We've already had 3 opcodes happen, the load, and the add. Store that result in this place in memory. So that's 4 opcodes going on. So just very fundamentally, it's just doing that over and over and over. It's got a series of numbers that it's responding to. And it's really pretty incredible that we can do all this pretty stuff, the game playing and using the internet and the graphics modeling and all the miraculous things that computers do just based on some silicon that's responding to numbers. So along with computers, the processing unit there is memory. Memory holds the data that is being used at that moment. If you're going to add 2 numbers together, the chip is not going to be able to add those 2 numbers unless they are loaded into memory. Along with that RAM, there's storage media, storage devices. And again, this is talking like in the 1990s when people actually had disk drives and stuff like that. Nowadays, you buy a laptop, there may not be a single spinning thing at all in it, certainly not on your phone or whatever. But the idea of storage media is that it's a material on which instructions, data is stored. That was the magnetic, stuff in your disk drives, or the chrome layer, the metal layer on a CD or whatever. And then the storage device is the one that read that stuff from the magnetic media or from the spinning platter or whatever. Nowadays, what does everything use? If you don't have a hard drive installed on your phone, what is it using? How's it keeping data in it?
Flash memory?
Yeah, it's got flash memory. Why is flash memory cool? Because it doesn't involve anything spinning. That sounds silly, but any mechanical point of failure, anything moving inside of a computer is a point of failure. Also, it takes time for a rotating device to get you the data that you want. Computers run insanely fast nowadays. Gigahertz. That means billions of times a second a program can be doing something. But then it wants data from your hard drive. It's got to issue a request to the hard drive, and it's got to wait for that platter to spin that data over there, read some bytes from it, continue reading. That's an astronomically long time as far as the computer's concerned, that input stage. And if it's reading from some form of solid state memory, storage instead, like flash, then your system works a lot faster. That delay in pulling from the hard drive is almost eliminated. So that's why nowadays people buy laptops, with flash storage in them, with solid state drives, because they're so much faster. Also, they run less with heat. There are a few drawbacks to flash RAM, but those are pretty much solved by engineering, which is that you can only change the number of data on it a certain number of times before it's possible that spot on the solid state drive will no longer work. But anyways, so nowadays the idea of memory, RAM used to be that stuff that disappeared when you turned your device off, and then your drives was the stuff that kept the memory even when you turned your device off. So nowadays all that's kind of blurred. You still have RAM in your phones and you still have your storage, but the storage is the flash, is the solid state memory. How much time should we spend on this one? We'll skip that one. So there is a circle of magnetic film here, and there's a magnetic head that's reading and writing to it. Before that, if you used a computer in the early 80s, you may have had a tape drive that used a cassette, or you may have had, a very expensive, fast tape drive for doing backups or whatever, those were still common for a long time. Alrighty, SDD cards, flash drives, used in digital cameras, handheld computers. Why is a computer so powerful? They are fast. That's a really important thing about them. The calculations that they can perform, the faster the computer is running, the more useful they are. The kinds of games that people have, on their PlayStations or on their computers or on their phones nowadays are just incredible compared to what you could have, in the 80s, because the computers are so astronomically faster than they were, and with astronomically more expansive spaces of memory in which to store data. That means that it can repeat an action over and over and over until it gets it right, until it performs the correct calculation, or it can continue to do so. It can perform lots of calculations in a short amount of time in order to display stuff on the screen. Reliability. Well, that just means that if you run the program 2 times in a row, you're supposed to get the same answers if given the same input. Let's kind of skip that. Why do we need a network? We like sharing resources. I want to be able to print, to some other thing. Your resources can be hardware devices. I want to write my data out to a server. I want to load my programs off the network. I want to be able to pull data off the network, So generally, what do we call the network nowadays is the internet. And we download our applications from the internet. When they run, they're probably talking to other servers on the internet. We're not going to do a lot of network-based programming since this is an introductory-based course. We will write at least one program that goes out on the internet, pulls data in from a web page, and then performs calculations on it, which is kind of cool. Alright, conceptually this is kind of skipping something. We have our hardware, and then we have our, quote, software. Software is the stuff that makes the computer know what to do. It is a series of instructions to follow. If you were a person and you were trying to get to Walmart, you would need to know how to get to Walmart. You would either need a map, or you would at least need to have some kind of algorithm in your head that said, okay, I know how to walk. Those are your instructions. I know how to go downstairs. I know how to ask somebody where the Walmart is and walk in that direction. So the software are the instructions that it has to follow. It's a series of instructions that tell the computer what to do. Some textbooks will break, software up into several different categories. You'll have application software. You have system software. Application software being your word processing stuff and the things that the end users like to run, and the system software is the software that's used to maintain the system upon which those applications run. Every program, well, I won't say every program, but a program will have a user interface. Why did I add that little caveat and not say every program? Well, because there are certain kinds of programs called services, or tasks, or processes, which run behind the scenes and you don't see any user interface at all. So for example, when you're running Windows, you ought to be able to pull up the task manager. And the task manager will show a list of applications. This is everything that does have a user interface. So I'm running, 6 or 7 programs right now. And then it will show the processes. These are the things that don't have user interfaces, but they're still programs. There are printer drivers, and Chrome actually launches a whole bunch of different processes in order to run. The camera software that I'm using has a background process that is running, and so on. So even when you first load up your computer, if you're not running a single program, if you go and you look at the process manager, the task manager, whatever you call it for whichever operating system you're on, you're going to see a whole bunch of different things, because even when the computer's sitting there doing nothing, it needs to be ready to do what you want it to do. So it's got to have, the operating system loaded, and the operating system is composed of a lot of pieces of software waiting to do your bidding. So along with system software, operating system. Kind of blurring, but the system software is the stuff that you manage the computer with. The operating system is the stuff that runs the computer. So system software might be, the thing that you use to go and format your hard drive. The operating system is the layer upon which we launch all of our applications, which we move files around. You're used to using Windows or your Mac or your phone. You're interacting with the operating system when you're doing that. Different kinds of operating systems. Command line, or not operating systems, user interfaces. Command lines. Command lines are when you pop open some window. What I'm doing is I'm going to the start box, I'm typing in CMD. There. If you've been around a while, you know this is the DOS prompt, or something like that. Or if you're a Unix guy, you call it the terminal or the shell. You can type stuff into it. That's a command line interface. It's a command line. Right there's our line where we type stuff in and then we run it. Most of our programs are going to be command line programs, meaning that they accept, typing and then they display letters on a screen. We won't have to go to the command prompt in order to do it, but it's going to look pretty similar to that. Then there are graphical user interfaces. you know, the Mac operating system, the Windows operating system, the stuff that you install on Linux in order to give yourself a nice graphical, you know, easy to interact with way of using it. And then touch. You know, the ability to zoom in on something by spreading your fingers apart or whatever. How many of y'all, I mean, have touched a non-touchscreen window and tried to zoom in on a picture by doing that? I know I have, and then I feel stupid about it. It's because I don't have a, you know, a laptop with a touchscreen yet. So the command line interface, the user interacts with the program by typing into the command window. So once we pop open our command prompt, I'll do this again, start CMD, and then if I type net, N-E-T, on Windows, it says the syntax of this command is, and it gives us some information about how I'm supposed to use the net program. These are called command line parameters or command line arguments. So if I type net and then follow it with one of these words, it will do something. I'm vague on that because I am not a systems manager. Okay, so I just typed in net statistics, and it's telling me that, oh, you can do it for one of these two things. Net statistics, workstation. All right, there, I get some information about it. So that net program, NET, is a command line program. It's actually, yeah, that's enough of that. So if we type in net space use, it will show us a list of the drive letters that this Windows machine is configured with. So supposedly I have an R drive, a U drive, a V, a W, and an X, and a Y. Now the word drive is, you know, ambiguous because it's not a hard drive. That's C drive. I can go to the C drive. But anyways, so I should be able to type U:, and it will activate it. It says it was disconnected. It's just because I hadn't accessed it yet. Do a directory. Oh, I see a whole bunch of stuff now. So if I type in net use again, I will see that the U drive, the mapping to that server, there's a, you know, a volume out on a server somewhere that is we are connected to in order to be able to save stuff to that. Speaking of which, I strongly recommend that you go and you buy yourself a $10 little, you know, USB flash drive and then copy all your work that you do in this class to that. Because there's no guarantee that the computer that you're sitting at today won't crash and be replaced by something or reformatted, you know, by the next time you come in here. So if you just leave all your work on your computer, it's possible that it won't be there when you need it. Now, at the end of each class, I want you to upload what you've done, so it's not like everything is lost forever, but it's nice to have everything, you know, in your pocket. So along with command lines, there are graphical user interfaces. You point at graphical objects on the screen with a pointing device. One time people were calling, or there was kind of a conceptual machoism where people would think that the graphical user interfaces were kind of lame because they didn't want to have to click on pretty pictures. They just wanted a nice command prompt in order to do things. So, that was back in the early days. Now everything has a graphical user interface. So they called it the WIMP interface, standing for Windows, Mouse, and Pointer. Yeah, kind of childish. But anyway, okay. So more traditionally we call it GUI, graphical user interface. Didn't I have another chat window going? All right, anyways. So everything you interact with is an object. When you go on and write more sophisticated programs, you will be learning the ideas of object-oriented programming. This class does not really focus on object-oriented programming. We will just keep nudging against the idea as we go along. It is a programming paradigm which lets you make things that you can reuse. The idea of an object is like the ability to display a menu on screen. This is a bad choice because it's not displaying menus, but okay, a window on screen. Every window that is displayed here shares some common attributes. You know, they all have a position on the screen. They all have a width. They all have a height. So those are objects. somewhere somebody has defined what a Windows object is, and then the various things that you can do to that object, and that way they can reuse that code over and over. Each time your program needs to create a new window, it can call upon that. Multiple programs are sharing the concept of the windows or the menus or the buttons. Those are all objects. We'll see other forms of objects as we go along. Okay, so as kind of a side excursion, graphical user interface. The input device, the first trackball. Check that out. That really is a bowling ball. That's not deceiving your eyes. So people use trackballs, you know, if they're getting repetitive, you know, injury or whatever. That was pretty much the first device that would let you move a cursor on the screen in a more natural format than just hitting the up, you know, or the down cursor or whatever. And so then the mouse. What is a mouse? Well, if you remember mouse balls, it was essentially a trackball turned upside down, you know. But before that, the first mouse actually had two rotors, and this must have been, you know, very unpleasant to have to use, because if you were going to roll it, you know, up the screen, you'd have to tilt it one way and get it to go over, and then if you were going to go to the side, you'd have to tilt it another way and get that wheel to go over. That's really lame. Once they got the balls in them so that they could roll around like a trackball, it was far better. So these came along like in the 50s, these in the late 60s. Graphical user interface, a 3-button mouse. He's got 3 buttons on his mouse. He's feeling cool. And also he's got a chording key set mechanism. That's where you could issue commands into it as though you were playing a piano. You know, 3 fingers does something, 2 fingers. 2 fingers, you know, whatever. Did that take off? No, people don't use that. Other input devices, light guns. It's the same idea as the light pen. You know, people don't use light pens anymore. Instead, they just make touch interactive screens. So graphical user interface examples. The idea of a graphical user interface is that it can model a real-world looking thing like this mixing software here with all the dials and stuff like that, but they don't have to. You know, conceptually, whenever first being introduced, you know, in the 80s, the guidelines were try to model, you know, a physical object. That could be taken too far. You know, does your library of books really need to be, you know, on a wooden shelf like that? Does your you know, does your text, does your notebook program, your notepad program where you keep your contacts really need to be leather bound or not? Not really. That's just fashion. Nowadays the fashion is going away from the realistic looking portrayal to the flat portrayal. It's like somebody decided that we went too far in making things look 3D, and so now we're going to go back and make programs look like they were written in the 80s again. So, you know, one version of the iOS calculator looked like that, and then an update came and it looked like that. So that's just fashion. Called schoolmorphism is the technical term for making something look like it's a representation of a physical object. And Apple got made fun of for their schoolmorphism of their leather books, you know, in the operating systems, and felt backgrounds, and, you know, and wood and stuff like that. I think this lecturing stuff is getting old. Let's go just a little bit farther. What is system software? System software are the programs that control the operations of the computer. You have utility programs that do maintenance on your computer. Like if you're going to, you know, run a check disk program on your computer to make sure, you know, that the drives are working okay. Managing the computer, its devices, or its programs. You need to install a new printer or something like that. The operating system is a set of programs that coordinates the activities among the computer hardware. Yeah.
They just put me in this class right now because I dropped in the class. Is okay if I just
Oh yeah, just go ahead and sit down. Be warned that those 2 computers there, you won't actually be able to log in, but you can listen to the lecture, and if you found another desk, I guess there's one back there, you could actually log in.
All right, thank you.
Sure. And then there are the applications. The applications are your games and your word processing, your spreadsheet, your database. It's stuff that does something. That's why you actually have the computer. Nobody buys a computer just because they like installing, new device drivers. Instead, you want to use it. Nowadays, everybody uses their computer for the internet. It's almost like the internet is their computer. If you buy a computer and it can't get on the network, then you're essentially, dead in the water. What is the programmer? The programmer is somebody who develops application or system software. They write the instructions that direct the computer to do what it's going to do, to process the data. Yeah, this is getting tedious. Why don't we stop that lecture here? Let's actually get a program going. So, go to your little start box, click on the Windows, type in IDLE. And then choose, it'll say something like idle Python 3, 32-bit, something like that. All right, this will launch something. Well, it'll launch the idle program. Idle is an editor for editing Python programs, Python being the programming language that we're learning. But when it comes up, it pops open what looks like this command prompt here. Idle is kind of separated into two things. It's got this shell. The shell is where you can type commands directly into Python and see the results. And then it has the ability to write programs where you chain commands together. So here's the shell. The shell's just sitting there with a cursor. Like, type in the words print parentheses, and then inside those parentheses, put some quotes.
Can we put spaces?
You don't have to put the spaces. I'm putting the spaces there to make things easier to see. Okay, and so what I typed was print parentheses, quote, hello, end quote, in parentheses. And I hit enter, and Python happily answers back to me, hello. Now that's not a program. I didn't write a program, but I did give it an instruction. A program is a series of instructions. Let's write a really complicated statement. A is equal to input, parentheses, give me a name. Or what is your name? Whatever, Now when I hit enter, it's going to say, what is your name? My name is Jeff. So that is another instruction in this language. Print was an instruction. The input command is an instruction. When I ran the input command, what Python did is it displayed the message that I had told it to display, and it sat there waiting for me to type something. And when I did type something and I hit return, the results of what I typed in are stored in that variable, A. I can prove that. I can just type A and hit enter, and it'll say, okay, Jeff. Well, if I want to use that, this is what's known as a variable. A variable contains data that we typed in or that it read, from the drive or something like that. So we have a named place in memory that contains our name. The name of that variable is A. So why don't I do this? Print, parentheses, quote, hello, end quote. And it doesn't matter whether you're using single quotes or double quotes as long as you use the same one on both sides. Comma, and again I'm just using spaces to make it easier to read, A. And it says, hello, Jeff. So what happened? This gave us a chance to enter some data. We did enter some data. It was stored in this variable, A. A now contains the word Jeff. So when I did print hello, comma, A, it printed hello, Jeff. Notice that these have the quotes around it, and this doesn't. If you put quotes around something, it's called a string. It prints it out exactly. It printed out the word hello. If you don't have quotes around it, it's not a string. It's not. So it will instead print out the contents of A. If A was a number, like 1, 2, 3, it would print hello 1, 2, 3. We can do that.
What was the purpose of the comma?
It separates. You could put a whole bunch of print here, like this. Print, I love programming. That's a silly example, but each thing separated by a comma. You can tack on as many as you want. Does that make sense? So we'll be using the print statement a lot. These are actually called arguments. This is an argument to the print function. This is another argument to the print function. An argument meaning a piece of data that's sent to that function in order to get that function to do what it's supposed to do. And you separate the arguments with commas. So let's do some math. X equals 1, 2, 3. Y is equal to X times 2. Print Y. 2, 4, 6. Everything that this interface is coloring purple, at least on my screen, is what's known as a built-in function. We can also define our own functions. We're not limited to just the words that the language has told us we can use, which are the built-in functions.
What would the like would like what would it be? Would it be an argument as well? The print, or would it be?
Yeah, you can put anything you want to inside of a print statement.
Does that count as an argument?
That's an argument to the print statement. Yeah, and it's a variable. Y is a variable that's being used as an argument into the print statement. So let's actually write a program. Yes, sir.
If you change X, Y doesn't update on its own though.
It wasn't supposed to update. I said X is equal to 1, 2, 3. If I still print X, it's still going to be 1, 2, 3.
Well, I changed X and then I printed Y and it was still 2, 4, 6.
Aha! Very, very, very good question. Let me close this version of the shell and relaunch it so that it's up at the top of the screen. That is an incredibly good question. X equals 1, 2, 3. Y is equal to X times 2. Print Y. It's going to print 2, 4, 6. Now X is equal to 1,000. Print Y. Why doesn't it say 2,000? And the reason why is because this is not a function. It is just a command. It's like I tell you to open the door. That door is still open no matter what else you do. We copied something into Y and nothing has ever changed Y. Things happen in the order in which they are given. If we want this to be repeated, we would have to type in Y is equal to X times 2 again, and then we would see it. Y is equal to X times 2. Print Y. Now we will see the 2,000 that we were supposed to. And I will loop back to that concept. But a lot of people think that just because their program has this statement in it somewhere, Y is equal to X times 2, that it's going to keep updating the value of Y. That no matter what X is, that Y will always equal double to X. No, it's just at that very moment in time does it equal double what X is. If X changes, then Y is no longer equal to its double until it has been updated, until another command has been issued. So it happens in sequence, top down, although there are loops and things like that that can make the sequence more complicated. So do File, New File. And right off the bat, I like to save the program that we're going to write. Don't do File, Save As in here. We don't want to save this shell. You know, if you see a whole bunch of stuff like that, that's not what I want you to save. Instead, I want you to do File, New File, get to a blank screen like that, and then do File, Save As. And it always defaults to saving to somewhere deep down in the guts of your Windows program directories. Program files 86, Python 35. If you save programs into the directory in which it's offering, it may break Python. And that sounds like an exaggeration, but it's really not. Instead, you want to go to a different directory. What I'd recommend is create a directory, a folder off the desktop. Just click on desktop, do new folder, call it programming or CIT1113 or my name is Joe or whatever, you know. And then go into there, and that's a good place to save all your programs. But you'll have to do that each and every time you launch Python. Unfortunately, it will not default to saving into that new directory. You always have to click Save As and go there.
It says on this one, it says need permission to perform this action.
Save them in documents?
Yeah, you might try going to Documents instead. Okay. See, you're in the Python. If it comes up and looks like this, we're not going to be able to do anything in that directory except save files into it, which we really should not be doing. So click either on Desktop or Documents. Get out of this system directory. Then you can make a new directory. So click on Desktop, then make a new directory. Then let's give it a name. Let's just call this one hello.py. PY stands for Python script.
Oh.
All right, so previously we were issuing commands into the Python shell. Why is it called a shell? Because Python's sitting there, and then the shell issues commands to it and displays them back.
Wait, what?
We're not really touching Python. I mean, pardon me?
Never mind, I got it.
Okay. Now we're going to write a program or a script. It's a sequence of commands. We could do all of these things. X is equal to 1, 2, 3. Y is equal to X times 2. Print Y. X is equal to 1,000. Y is equal to X times 2. Print Y. And that's enough. Then save your work and then run it. The way you run things is you click under the Run menu and choose Run Module, where you hit the F5. Now you may have syntax errors. It may not run. But this is the idea of a program. This is the difference between a series of commands entered into a shell, wherever that was, and an actual program. The first thing we were doing is we were just issuing commands. Now we have chained commands together, so we have written an honest-to-goodness program. And when I ran it, it printed 246, and then it printed 2000. That not being terribly interesting, let's make it have an input statement. Name is equal to input parentheses, quote, what is your name? Now we have a variable called name which contains the result of this input function. We can do stuff with that variable. We can print it out. Print hello, comma, name. Let's do one more. B-Day is equal to input is today your birthday. So now we've actually got 4 variables going on, but we're not going to touch X and Y again. You know, those were just numbers designed to illustrate that we were manipulating series of instructions. All right, now we've asked if it's our birthday. Why don't we give them a clue as to what kind of input we are expecting? Because they don't know whether to type in yes or y or in or the word no. So inside my input statement, I'm just going to tack this on, y/in. The reason I did that is to let the user know what kind of input I am expecting, so that they don't just type yup and expect it to work. Now we're going to use an if statement. An if statement performs a selection to where some code gets run if the if statement is true. And either nothing happens if it's false or some other code is performed. And I'll show you. If bday, we have to use two equals here. Equals equals, quote, y, quote, colon. Now here's where Python is a weird language. Tabs matter an awful lot. I have to tab after this if statement, and everything under it needs to be lined up exactly. So if it is our birthday, we're going to say happy birthday to you.
Question.
Mm-hmm.
Under the conditional there for the y, if y, is that, is it gonna be, caps cognizant? Like, if you put a lowercase y in as your input, is it?
A very good question. Case matters.
Okay.
Case is very important. If they type in a lowercase y and I'm looking for an uppercase y here, then it's not going to work. I could expand this comparison to check both for lowercase or uppercase, or I could convert the data so that it's one or the other so that we would know what we were looking for. Okay, so let's tack on an else. The else is going to be what it does if it's not our birthday. So else colon, and then another tab. Notice that else is not tabbed over, but what's going underneath it is. We're going to print, aw, too bad. And then lastly, at the very bottom of the program, I'm going to print the word done, just to indicate that the program is in fact done. Is that necessary? No. All right, if I did not make any typos, here's what the program is going to do. It says, whoops. Once my shell gets full of too much stuff, I just close it, and then I rerun the program so that it starts off fresh. What is your name? My name's Jeff. Hello, Jeff. Is today your birthday? Y-N. I'm going to type in Y. And it says, happy birthday to you. Done. If I run it again, which I have to do by actually going back to the program itself and doing run module, and I type in a lowercase y, it's not going to recognize that it was my birthday. So since I typed in a lowercase y, it says, oh, too bad, because it was checking for an uppercase y. If we feel like being more generous and letting them type in lower cases, there's two things we could do. One is we could check for the lowercase version as well. Now here's what we do not want to do. Let me show you the bad thing to do. Don't do this if birthday is equal to lowercase y, you know. Instead, we're going to use what's known as OR. OR lets us chain conditions together. And we will talk a lot more about that later. This is just an introduction. We're getting our feet wet. OR bday equals equals lowercase y. Now it lets them type in either one. I will show you a syntax that people wish works, but that doesn't. People wish that they could type this. If B day is equal to Y or Y. Looks good, but it doesn't work. You have to do the whole thing. So notice that sometimes we are using single equals and sometimes we are using double equals. Where do we use the double equals? We use the double equals when we are doing comparisons. If you use a single equal, it means copy what's on the left-hand side and put it on the, copy what's on the right-hand side and put it into the left-hand side. So whatever's on the right here gets copied into X. Whatever's on the right here gets copied into Y. If we put a single equal here, it would mean, although it wouldn't work in this language, it would take this, what's on the right-hand side, and copy it into that. It would erase what was in B day and replace it with a Y. We don't want that. So we use a different symbol that means equals, whether comparison, not copy. This is technically known as the assignment operator. It assigns a value into that variable. An assignment operator. An operator is a symbol. Star, the asterisk, is an operator, meaning multiply. The plus sign is an operator. The equal sign is an operator, and its function that it performs is to copy a value from whatever was on the right-hand side of the equal sign and store it into whatever's on the left-hand side. You have to use double equals whenever you write if statements. I guarantee that you will write if something equals and you will skip doing the double equals there and the program won't work. Somebody's going to do that. More than one of y'all is going to do it. I'm probably going to do it up here and make everybody do it by mistake. So I'll try not to. Then the other thing you might do is you're going to get used to typing in this double equals, and so you think it needs to be everywhere. No. If you're doing some math, use single equal. If you're doing some comparisons, use double equals. So you will only use double equals in if statements and in while statements. Other languages have more constructs than ifs or whiles, but this one has ifs and whiles. So we have these words highlighted in orange, and we have these words that are highlighted in purple. The orange words are what are known as keywords. That really is not that useful. Let's get rid of that one. So functions are the stuff in purple with this editor. The keywords are the stuff in orange in this letter. Back in the old days when people only had, one color monitors, green and black or whatever, you did not have these niceties, these fanciness. It's called the color context editing or something like that. Makes the program easier to understand at first glance. So what's the difference between a function and a keyword? A keyword are the actual words that define the language itself. Every language has a set of keywords, and those keywords are special. You're not allowed to use them for anything else. I can't go into my shell and then type in, I'm going to launch a new version of the shell. Excuse me, close that one, open it back up. I can't say if is equal to 3. Syntax error. Invalid syntax. Now this is your bane. You're going to start seeing this a lot and it's going to annoy you. Sometimes it's hard to spot the syntax error. But in this case, the problem is we have used a keyword. A keyword is a special word that has a very specific meaning to the language. And we are not allowed to use it for any purpose other than what is defined. So we've seen 2 keywords so far. Three, actually. We've seen if, or, and else. So, if, or, else are all keywords. Then we've seen some functions. The functions are the things in purple. What functions have we used so far? Yeah, we've used just 2 so far, I believe. Print and input. Are there lots of functions? Yeah, there are lots of them. Are there lots of keywords? Let's see if we can go find a list of Python keywords. Google is your friend. Python keywords, I Google it up, it comes up with elif, else, except, exec. List of keywords in Python programming. There's a whole bunch of them. Looks like about a 5 by 1, 2, 3, 4, 5, 6, 7 grid. How many of these are we going to use? We're probably going to use about 10 of them. We're going to use if, or, and, else, elif, import, break, and return, and while. I lost count. About 10 of them. The rest of them are to do some more sophisticated stuff that you would learn in a later class, like the scripting class or in other programming classes. Almost every programming language has some variation on these words. They almost all have an if or an or an and, or a while. It's kind of funny to think that they're almost all are written with English words. If you were born in India, I know that, lots of people are taught English there, in an early age, but you're sitting down and you're essentially programming in even more of a foreign language than it is to, those of us who are just seeing programming for the first time. So some programming languages were in the past localized to, the region, but mostly people just learn to program in English. However, they write all the descriptive text and whatever in their own languages of choice. So functions, besides if and print, there are going to be a lot more of those as well. Python built-in functions. Oh boy, there are a lot of them. Are we going to use that many of them? Probably not. Here's one called ABS. Stands for absolute value. Here's one called float. We will actually wind up using that one a lot, even though you may not know what that does without hearing about it. Sum, S-U-M. There's good old input. Anyways, you can see that there are a lot of functions. Do you have to memorize all this stuff to be a good programmer? No. What's important is to memorize the concepts. And then you can always look up how to do it. Yeah. It's more important to know what a while loop is, and then you can Google up the specific syntax for a while loop in the specific language that you're trying to implement. So let's use one or two of these. There was the ABS one. Go back to the shell. Click on Run Python Shell. If you want to, you can close the Python shell and then open it again. So yeah, you have a blank, nice, pretty one. X is equal to -3. X is equal to ABS X. And then if we type just X all by itself, it essentially does a print on it, and it prints the number 3. Prints the value of the X variable. So this was a function. Took the absolute value of, took the magnitude of it. The absolute value is the number that has the negative sign removed if there is one. There was another one called POW. That probably means to the power of. X is equal to POW 10 to the power of 2. And then hit just X and hit enter. Now 10 to the power of 2 is 10 times 10, which is 100. Now, some languages have a symbol, an operator for indicating raising something to the power of something else. You probably are used to typing something like this. Y is equal to 2. Don't type this because it's not going to work. To the power of 3. It's too bad that the Python doesn't implement that, but it doesn't. That'll just be a syntax error. Oh, great. Well, I don't know what it did, but it didn't do what we wanted to do. 2 to the power of 3 is not equal to 1. If you want to raise something to the power of something else in this language, you could either use that built-in function POW, or you could do this. Y is equal to 2 star star 3. 1 star means multiply. 2 stars, 2 asterisks, mean to the power of. So 2 to the power of 3 is 2 times 2 times 2, which should be 8. So let's go back to our notes. We've seen a couple more functions: print, input, ABS, POW. We have seen some operators. Equal is known as assignment operator. Assign a value. Addition, multiplication, subtraction, division have their normal meaning values. And then there's also asterisk asterisk, which means to the power of, or exponent. A lot of languages don't even have an exponent operator at all. They just require you to call a function. I think it's handy to have one built into it. What's the difference between using POW and using star star? Good question. Do I have a good answer for it?
Well, you put variables in it.
Well, they did the same exact thing.
Well, with the POW, you can probably put variables in it. With the star star, maybe you can't.
Yeah, you can put variables when, yeah, that's a very good guess. It's not actually correct. Let's demonstrate both of them. X is equal to 3, y is equal to x to the power of x. So 3 to the power of 3 is 27.
Style.
Yeah, style. I don't really know. I can't come up with a good reason for using a POW function as opposed to star star. Except that in other languages there is no star star, so you have to use POW.
Maybe it's easier to read.
Yeah, could be easier to read. So what is a variable? A variable is a place in memory for storing information. My typing has gone downhill today. There we go. Variables have a name, they have a value, and they have a type. Now, some languages are known as strongly typed languages, meaning that if you create a variable and it's supposed to contain a name, you're not going to be able to put a number in it, or vice versa. You know, in our program that asks you for your name, if I go back to that program, that hello program, and I run it, it says, what is your name? It doesn't care if I type in 1, 2, 3. It still works. However, if it asks me for a number and I type in a word instead, it would crash. What do I mean by that? What do I mean by crash? Go back to your hello.py program. Let's make an edit to it. Right up here, instead of this x is equal to 1, 2, 3, comment that out. Comment it out means put a hashtag in front of it, put a pound sign in front of it. It's red now, meaning that the program is ignoring it. Instead, we're going to do this. X is equal to input. What is x? Baby, don't hurt me. There we go. There we go. Now, this is not going to work. We're going to see an error when we run it, because there's one more statement we need to add to actually get it to work. So what is x? I want x to be 1, 2, 3, or something. Okay, it didn't crash, but it did not give me what I was expecting. Because what is 1, 2, 3 times 2? It should have said 2, 4, 6. Instead, it coughed up 1, 2, 3, 1, 2, 3, which is a really interesting interpretation. what's happening is that X is not a number at this point. It's what's known as a string. If I go back to the shell, close my currently running program so I can launch a clean shell. If I type this, X is equal to 100, and then I do Y is equal to quote 100, those are two completely different things as far as the computer is concerned. We think, that's a 100. This is a number. This is what's known as a string. A string is a series of letters. A string is not a number. You can't do math on a number. The computer would have to convert that string into a number in order to do anything. And that sounds kind of pedantic, but it's not really. If you're typing stuff in on your little keyboard, on your phone, everything you type in is a string. And the program has to convert it to a number before it can do anything. And same thing like if you're typing in, filling in an internet form and it wants to know what month you were born in. You're typing in a 6, but that's a string that the program that sits on the server will later have to convert into a number. You can't do math on a string. So if I do print, or not even print, y times 2, it prints out 100, 100. It's just doubling the string. If I had the word Fred here, it would print out Fred, Fred. If I do x times 2, and that's a little oddity of Python. Most languages don't let you double strings like that. If I do x times 2, it comes out with what I consider a good answer, 200.
Excuse me.
Uh-huh.
When I ran the after I put what is X,
Yeah.
now it's saying that I have an invalid syntax for the or. Is it because it was lowercase one? Well, no, because it wasn't.
I don't know. I'll have to come back there and look. I don't have a good answer for you right away.
I deleted it just to try to fix it, but
Go away.
even after I took off the input what is X, it didn't.
Well, let me look. So you had your program here. You ran it. What did you type in? Anything? I mean, you typed in a number and it typed 100 and it says, what is your name? Joe. Hello, Joe.
Oh no, it didn't let me run it.
Okay, okay. Well, recording this. For example, if I wanted to add a second print statement, but I accidentally spaced it too far, print. Hope the cake is good. That's going to be a syntax error because it's not lined up. It has to be lined up, and worse, it has to be lined up with the same kind of characters. If you use the tab key and then you mix that up with spaces on the next one, then it may complain about it. So let's run it. And I don't care if you actually did this or not, but it says unexpected indent, meaning that I have to fix it. I have to make them line up exactly before it'll work.
So you just need to, instead of using space, use tab?
I use tabs. I find it easier to use tabs.
Yeah.
This program is configured so that if you hit tab, it just inserts 4 spaces rather than doing something funky like, how to explain. You've seen programs where if you hit the cursor once, it'll jump all 4 spaces, like in Word. Some editors do that, some don't. It's good that this program converts tabs to spaces, because otherwise you wind up into things where if I tab this one and then I spaced this one over, it would think that they were
sometimes it's not
different.
exactly. Yeah.
Right, right.
Gotcha. So when you say they line up, you wouldn't line up exactly like that. It's not like the first print is 1 tab, the second print is 2 tabs.
Right, that would crash.
Okay.
The amount of tab doesn't matter.
It's just the
I could do
It's
this.
just the fact that they're not on the same.
Right,
Gotcha.
right. All right, I think we are about done for the day. I think we have absorbed enough. So a variable has a name, a value, and it has a type. That's what I was going on, and I distracted myself. The type of the variable, we have 3 different types of variables. We have strings, which are things like names or anything enclosed in quotes. We have ints, which stands for integer. An integer is a whole value. What does whole mean? It doesn't have a decimal point. It doesn't have a fractional component. Whole numbers. Like 1, 0, -1,000,000, whatever, you know. And then lastly, there are floats, which stand for floating point. 1.3.0, 3.333, you know, whatever. Anything with a decimal point is considered a float. If it doesn't have a decimal point, it's considered an int. Weirdly enough, as far as the computer is concerned, well, I'll just illustrate this rather than say it. Go back to my shell. If I say x is equal to 3, and then I do type, T-Y-P-E, parentheses, x, it'll tell me what it is. Oh, it's an int. It's an integer. It's a whole number. Then if I do y is equal to 3.0, and then I do type of y, it says it's a float. As far as the computer is concerned, a 3 and a 3.0 do not mean the same thing at all. They are stored in the computer in a completely different format. It sounds ridiculous, but it's true. Now, the programming language may choose to, you know, round the 3.0 off to 3 when it's doing calculations and stuff like that, but they are actually different data formats. But what's really important to know is that if you're asking the user for a number, it has to be converted into an int or a float before we could do any math. So remember the program hello where we asked for a number and then we printed out twice that number? The reason it printed out 123 123 or whatever is because we didn't convert it to an int, or we didn't convert it to a float. We're going to use a new function for that. So right underneath that input statement, that's just a comment to make note of where we are, do x is equal to int x. Now when you run it and you type in a number like 123, it won't print 123 123, it'll print 246. So we had to convert. I'm going to put a comment here to that effect. Convert to a number. But since we're not converting it to a float, it won't accept a decimal point. And here's an example of what I meant when I said that it considers them to be completely different things. If I type in 123.0, our brains think that that's equal to 123, and that ought to print 246. Instead, it prints blah. It vomits all over the screen. So that's not a syntax error, but it's a runtime error. A runtime error is when the program's cruising along, but then it gets some kind of data it doesn't understand, and so it blows up. And the reason why is anything with a decimal point cannot be converted to an int. So if we wanted to make this program a little more fail-safe and not crash if they type in a decimal point, we should change that int to a float, like that. Then it'll accept the data regardless of whether there was a decimal point or not. What is x? If I type in 123 point, it works. I could type in any value that has a decimal point, or I could leave the decimal point off, it will still work. You're going to be seeing this use of the word int or float a lot, because every time we ask the user for input, we're going, and it's supposed to be a number, we have to then turn around and convert it to a number. Let's go back to our functions, and we'll add two more functions, int and float. What does the print function do? Displays data on the screen. What does the input function do? Some random person give me...
Request input from the user?
Yeah, request input from the user and lets them type it in. Lets the user enter data. ABS. Absolute value. POW, to the power of. int. Convert the argument to an int. Float. Convert to a float. If a number has a decimal point, is it an int or a float? It is a float, standing for floating point, that decimal point. Alright, I just pasted that code that we did there at the bottom. This will be in notes. Text me with your name and the class number. So your homework is going to be to install Python at home. If you're not going to install Python at home, just type into a Word document or a text file or something and upload it, saying that you're not going to do it. So I want you to upload one of two things. One, a statement saying that you uploaded Python and that you got a program to work. You could just copy this stuff that's going to be in the notes out of it, or even if you just say print Fred, anything to prove that Python is working. So write in a Word document that says, or whatever your favorite form of document is, I installed Python and it works, or no, I'm going to use Python at school. I just want you to make that decision. And you can always change your mind. So that will be homework assignment 0. Why is our prof giving us a stupid naming scheme like that? The in-class assignments have letters for names. Today's in-class, the hello world, is an A. Then, and then B, and then C, and then D. The homework assignments have numbers instead. I start at 0 just to reinforce the idea that computers start counting at 0, and that will become very important later when we're talking about indexing and arrays. So, A is our hello program.
What page are you on? Or the folder thing?
Okay, I have terrible hearing. Just a second. Pardon me?
Where are you?
I'll show you. I hadn't created the folder yet. I've created it now. Go to our home page and then click on Dropbox.
Okay.
And then you'll see hello.py. Go ahead and upload that script that we edited and created.
Should we attach our name to it, or is hello.py fine?
What we really should do, hello.py is fine, but what I would like and what I failed miserably to do is I would like every program that you turn in to have your name up at the top
Commented, right?
as a comment, right? So put a comment up at the top. If you've already uploaded it without this stuff, that's fine. And then put, the class name, put the date, and then put some kind of description. First day's programming. The description could be more complicated if you're doing homework or whatever. You could just put homework 0, or 3, but it's better to actually give a description. This program converts Celsius to Fahrenheit, that kind of stuff. And I'll upload a specification for that. But as long as you remember to put your name and the date on it, then you're going to be good to go. If you cannot upload this today because you don't have an account in the class, just keep track of the program and upload it when you come in on Wednesday. If I did not read your name off during roll, or I missed, or you came in late, please to text me at this number, letting me know that you are here. It's really important, especially for the first week, to prove that you are here. So for the guys who came in, or for the guys who are not enrolled in the class, I don't mean not enrolled, but who aren't showing up in D2L, please send me a text saying that you are here. I will update the rolls when I can. Okay, so that's that. Whenever I do an in-class assignment, it will have the due date as showing as today. But if you miss a class, you're not going to be counted off late. As long as you go and watch the video and do it at home or whatever. As long as you get it done within 2 weeks. Now we're going to make the homework Dropbox.
Instead of homework, you should name it quests.
That's right. Your quest, should you choose to accept it. So the homework is due Sunday night. That gives us a week to do it. As always, if you turn in something before Sunday night, you get 5% bonus on it. If you turned it in after Sunday, you start earning debits. I will give more detailed instructions, but just remember all you need to do is install Python. You need to know where to install Python from, for example, so that's why I will upload instructions. But if you go to python.org,
There's no possible way anybody could fill this homework.
pardon me,
I said there's no possible way anybody could fill this homework.
right, right, except by not turning it in. Except by not turning it in. Okay, so go to python.org and then choose whether you're going to install Python 3 or Python 2. Do not choose 2. If you load it up on a Mac, it'll offer to download it for a Mac instead, whatever. So just choose it, do the download, install it, and then run idle like that. That'll prove that you got it all working. So I'll upload instructions and put them into the Dropbox a little bit later today. And let's upload the notes. There we go. Normally I do this kind of cleanup after I let y'all leave, but I want you to see where the notes are going to go. If we go to content, along with PowerPoints and textbook and syllabus, there will be 2 other folders, one called notes, one called videos. The notes are where we're going to type in the stuff. I will upload everything that I type in today there. So if you want to refer back to it, you know how to get to it. Just go to the course homepage, click on content, and you can find our notes folder. Or from the course homepage, down here in quick links, you can type notes, get that particular file. A lot of stuff will look better if you actually download it rather than view it in the built-in browser. So you can click on something like the notes, and then you go down there and there's a download button and you can download it. Especially PowerPoints. PowerPoints look absolutely horrible inside this little preview that it gives you. Alright, gang. Any questions? Then I will see y'all on Wednesday.
Ask mine earlier.
You say you uploaded videos?
I will. I will upload a video of everything that we did today.
Thank you.
Sure.